Well, let's see if this works today. Hello. There's Rusty Russ. I messaged you, Rusty Russ, asking about the stickers on your power supplies. Is this a good one? Is the pink color the bad one? Hello, King Nothing. Let us repair. Welcome, welcome. I just picked them up from the post office. Green is good. Okay, red bad, green good. Gotcha. Well, I actually dug through my broken supplies. Oops. What did I do with it? I just dropped that screw. And I had one. And I've been able to fix it. I was trying to get there's that screw. I was trying to get familiar with these things because I don't know that I ever worked on one of these. So I dropped the screw out of it and put that back in there. But this is another working one here. I was able to fix. So I did some homework on these things. I'll set that to the side, or maybe way over here to the side. I did do some homework on these things, so I'm not going in totally blind. This should be pretty easy to open since it's been opened before. Mine was like glued on one corner. Had to break the glue. So, come on now. Oh, no, there's another screw in there. That's why I busted mine. I forgot there was two screws in these things. I may have opened one of these before. There we go. Maybe if you take out all the screws, that won't happen. There we go. So there are two screws. I just remembered that. Here we are. Now I don't remember what all you changed on this thing. Looks like that chip's been changed, and that chip. Let me take a quick look under the microscope. Yeah, you damaged the trace there. I see that, but you've got it jumpered right now. Okay. And this DNP 012 way over here, looks like you've changed that. Okay. I did some research into this chip, the DNP 012. I mean, they use this chip in other power supplies. Several of the slim power supplies have it in there. And I was trying to figure out how it worked. Good morning, Carlos. Console Crackers, hello. Okay. Anyway, I was going to talk a little bit about this DNP 012. I made some notes on this power supply. Which one is that? There's some notes I put together on this DNP 012. Because there's no data sheet on it. Hello, Dave's Unbranded. So these are some notes I put together of what each pin roughly does. Might come in handy later on, but that, and I made some notes. Where's my other notes? On what the different ICs are doing, the different chips in here. So, might come in handy for somebody later on. But if I remember correctly, this thing actually starts. It actually starts and runs and then shuts down, which is good. I mean, that's great. That means you don't have any bad shorts. Or it would not try to run at all. It would blow the fuses immediately. But let me try to confirm that. Let me get my meter set up so I can watch the voltages. So we can monitor the PFC voltage there. Get another meter set up on maybe the output or something. So if I need to get on this side if I'm going to see that output. I don't have it into a load right now. I just want to see it come up. Confirm that. Okay, this is turned off. All right, can we see all this stuff? Yeah. It shows 12 volts briefly, and the PFC is running to some extent because it's going, you know, if it doesn't start, you're going to have like 160, 170 volts DC there. But you get like 300 and something. So that's good. Let's give it, let's see, can you see that? Oh, no. I'm just going to turn on this power supply and watch for these to come up momentarily. Well, the PFC did not start that time. Now you did have it starting. Is something knocked loose? Oh no, I'm sorry. You got a jumper. That's right. This has got that split supply. I'm sorry. You should have 5 volts, and then we have to enable it. That's right. I'm used to, you know, the PS5 supplies just coming on. We got our 5 volts. That's good. Let me get my tweezers in here. Get that back in there. And where's my favorite pair of tweezers? Let's see if we can see it run. Yeah, I forgot this has to be enabled. And well, come on, 5 volts. There it goes, 350. Yeah, I saw 350, and then it shut down. All right, just wanted to see that. Okay, let's get rid of this charge on this cap. Well, turn that off. That slipped. Okay, so we're down to like 2 volts. All right, what I want to try now, I mean, if that's trying to run, you don't have any major shorts. What I want to do, if I can show you on the schematic. Hello, JFix. Carthor. Let's take a quick look at the schematic. And looking at the function of like this right here, this circuitry right here. This is shutdown circuitry, and I have a feeling this is the problem. This is particularly is AC over voltage input shutdown. You know, turns on this FET, which turns on this opto isolator, which in turn probably pulls this low. It looks like it's got a 5-volt, pull up right there. So it pulls pin 11 low. So what I would like to do is I'm just going to lift one pin of this IC43 right here. Probably pin 1 or 2, one of those. I'll just lift it and we'll disable that and see if it runs. That was IC43, right? Let me get rid of that. IC43. Hello, hello, welcome. IC43. Which one of these is IC43? I think it's the odd one in the middle here. Yeah, 52, there's 43, right there. So let's lift one pin of that, if we can. Let's see. Doesn't particularly matter, just grab one of them. These have been soldered on. I think you were trying to check them or something, I think. Alright, okay. And these are, according to the schematic, EL1013s. Yeah, I do have some of these. Got quite a few of them, actually. Alright, so that is disabled. Which means I want to really watch my voltages here to make sure something doesn't, take off and put too much voltage across these capacitors here. Alright, so there's that. What's the easiest way for me to do this? It's just putting the probes here. The probes end up right in my way. So I was thinking about hooking up the dummy load there, the DC load, and because the probes just kind of stick up right in my way here, kind of block what you're looking at. Okay, turn that fan off. Tweezers. All right, now I'm going to give it. Well, I'm going to plug it in. Sorry. 160 volts. Alrighty. Is this coming up now? And I'm just going to be ready to turn it off in case I need to. No. What am I doing wrong here? That is not working. It is not enabling. Is that opto isolator needed? Maybe it doesn't function like I thought it did, because that is not working at all. Let's see. Is there 5 volts? Well, I got it turned off now. Is there 5 volts coming up? Yes, it is coming up. So is it staying up though? Like if I do this, nothing. Is the 5 volts still there? It is still there. I'm sorry, I'm going to keep hitting that camera. It's kind of right in my way. So, is this not? Let me flip this over. Apparently that thing does not work like I think it does. It's still plugged in, so I'm not going to grab it. I lifted, yeah, I see 43. Don't forget that thing is still plugged in. Welcome. Yeah, I was. If I had an extra, 5 pin, I would just cut it and twist the wires together. But I don't really have a whole lot of those. I'll probably do in a chassis somewhere. I could steal out. I just hate to destroy one of those. I think I've got some 4 pins. I'm pretty sure I do. For the later supplies that use 4-pin control. This is on. What is pin 11? Let me look at that again. Pin 11 of the, not that one. Over voltage. What is that measuring right now on pin 11, I wonder? Okay. Where's my ground? My hot ground. Right about in here. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. Yeah. Of course, it's low right now. It's just, I thought there was a pull-up on that thing. Wait a minute, I'm looking at the wrong chip. I just realized I'm on the wrong chip. That would greatly explain that. 11. 4.3 volts. So she is pulled high right now. Trying to figure out if that's meant to be high for it to run or low for it to run. High enable or low enable. Pin 11 is pulled up to 4.3, which I'm sure we see right over here. Yep, right there. And that's ground. And apparently with that high, it will not run. So it works the opposite of the way I thought it did. Let me turn that off a second. Let me discharge these caps. Okay. The problem with all these things like this is that there's no time to measure anything when they shut down. They just shut down. So that's why I was trying to disable one of the shutdowns. .9 megohms. Should have like a 1 volt diode drop. Yep, 1 volt. That looks fine. Absolutely fine. So it does not want to run. Okay. If that's how it's going to be. My solder broke on me. Tack that back down. So now, if I give you voltage, I go back over here to this DNP012, pin 11, 9, 10, 11. We're low, 1.26. The meter went to sleep. 1.26. Why is that not going all the way to 0? Kind of a half-hearted approach to switching there. Let's see. What do we have here? Pin 1 and 2. Well, it does not appear to be driven on right now. So here, though, 1.26. 1.26. This is on that IC43 opto isolator. 1.26. Is that normal? Now probably a good time to check the other one. I'll just mine's open already back here. I'll just grab it. I'll discharge this before I, go back and grab it and get bit. Set you there. Where is mine? Here's mine. So, is that normal when we're just sitting here like this? These are different opto isolators. I wonder, just a different revision of board? A little different color to it. It looks to be the same layout. Maybe a slightly different revision. I'm going to give this some voltage. What do we have here now? Make sure I'm trying to get this in the picture there. There we go. Here, 0.8. This is going lower. 0.8. What do we have over here? Not really anything. This is not turned on right now. Let me check from ground on, say, pin 1, 16 volts. Pin 2, 15.4. 16, okay. That is turned on. It does not like it when I put my leads across it, though. 16.3, 15.4. Remember that, 16.3 and 15.4. But in the end, just sitting here, we've got 0.8 of a volt going into that DNP012. I'm just thinking. I wonder. I'm thinking about starting running this one, and I'd like to see what that voltage is on this good board when it runs, which is going to be tricky. Get a clip lead or something. It's going to be a little bit tricky to get that measurement. Let me try this though. Clip lead, tweezers, 1911, right there, 8/10 just sitting there. And if I turn it on, stays at 8/10. So that stays low the entire time. Stays low when it's in standby, and it stays low when I start it. Stays at about 8/10. Okay. Okay. Let me discharge this one. There'll be a lot of going back and forth, I'm afraid. Find those terminals. Okay. Set you to the side. This is the good one. If I can put a check mark on here, just so I don't get confused in the middle of this. Okay. And if I do that over here, let's just get back on that pin of the DNP 012, get my ground. Turn it on. Now, what do we have here? 1.2. Turn that fan off. And if I jumper it to run, okay, I'm going to jumper it to enable. She stays at 1.2, doesn't she? And it's shut down now. And now that it's in shutdown, I meant to check earlier, is the 5 volts there, or does it shut it down also? Okay, that's the 5 volts. It shut it down also, didn't it? Yeah. So when the shutdown happens, it kills the whole thing, not just the 12 volts. It shuts down the 5 volt supply. Interesting. And that is now at 9/10 and dropping because the 5 volts went away. I'll cycle the power on it. We'll come back to 1.2. And what did we have over here? I think this is the hot. (16.2), 15.3. That sounds very familiar. That seems fine. Now this is a little different. I'm on the wrong ground. 1.26. 1.26. Is that a low enough logic level? Maybe. Let's see. So if I lift this off to oscillator, the pull-up takes this high. trying to think of how I want to defeat this shutdown. Remove the pull-up, or just short to ground that pin. That's an option. I was expecting, usually on the PS5 supplies, you can usually lift and disable. You can lift one of these pins. But it looks like on this one I'm going to have to force it the other way. Oh, come on, Meter, wake up. It's not time to sleep. You can sleep later. So what happens if I short that to ground? Short across those two. Let's find out. But I would like to be able to monitor my boost voltage if I'm going to do that. It's not going to stay, is it? Kind of just about have to bring my leads in from the other direction because of how it's laying. So these caps have 160 volts on them right now. Although it's probably bleeding off slowly. Wake up, meter. 100 volts and dropping. So what happens? What happens if I short across those terminals right there and hold that low? It's hard to tell if I'm making good contact there. I think I am, though. Okay. Oh, I turned the power off. Oh, I slipped. She's still shut down. I think, yep. Went to 360 and shut down. So this is not the shutdown that's getting us. Because I just disabled it. At least I think, unless my screwdriver's not making good contact. 360 is as high as I've seen it. Should be 400. Pretty sure I'm making good contact there. If I get on pin 11 over here, do like that. Yeah, 0. So, we're still hot. Go ahead and discharge it because I'll forget. Yeah, okay. Safe enough. Let me look at the schematic. Let me look. Let's look back at that So this is the one I was disabling. I was shorting right across these contacts to keep this pulled low on pin 11, which is one of the shutdowns, but it has other shutdowns. So we got to figure out which one is telling it to shut down. Because the 5-volt shuts down also. Which IC was that? Just a moment. The 5-volt shutdown pin, the command is going out pin 8, looks like. Pin 8. Right here. Let me. Wait a minute. Wait. Pin 8. Okay, yeah. Let me try to, yeah. The labeling is kind of weird. 5-volt standby. LH, it's the latch input to the 5-volt converter chip, wherever it is. Not there, right there. Yeah, connects to that point right there. And it pulls that, well, it turns on this opto isolator and either pulls it high or pulls it low. And it disables it. So our DNP012 is making the decision to shut this down. That's the feedback for the 5 volts there. The yeah, feedback, the correction voltage. That's all fine. It's the shutdown stuff that we're interested in. And I really thought it was going to be this one over here. So I'm saying this chip is the one that's saying, hey, it's time to go sleepy sleep. Now, is it doing it because of, like, it has temperature sensor inputs. It measures the, it gets a sample of the current to the 5 volts, you know, right here. Oh, I'm sorry, let me get, yeah, you can see that. It gets a sample of the 12-volt current over here. But it shouldn't be shutting down because of overcurrent, because we're not really drawing any current. It's not on a load. Shouldn't be a problem. So is it purely the PFC? Either PFC or temperature? You know, it's obviously not hot. It hadn't run long enough to get hot. I've seen these sensors crack though, and it'll think it's over temperature. That's something we can check. Resistance of this thermal sensor. Might do that right quick, like check from, like, say, pin 5 to ground. Just to quickly check that on the good one and the bad one here. I don't think that's it. But it sure won't take but a moment to check it. Let me get that out of the way. Pin 5 to ground. 1, 2, 3, 4, 5. 71 k ohms. Okay. And on the other one, one, 2, 3, 4, 5. 70 k ohms. That sounds fine. That thing's going to be mounted somewhere near the PFC or something, but it sounds like it's all good. 5. Just wondering where it was mounted. You'd have to hunt around and find it, maybe down here somewhere. But anyway, the resistance looks fine. So if that's not what it's complaining about, I have not tested all the optocouplers. I have not. And what I had, well, EL1013 should work. That's not what's in my, yeah, this has EL. This bad one has EL1013s in it. I do have those. I just don't have the one I'm comparing to, my supply. For some reason they use a different part in it. It's shutting it down. 12 volts comes in there. Let's check. All right, what other inputs does it get? There's the over temp. See, pin 11 was that AC input over voltage. That's the one we defeated. So it should not be a problem. I kept that low. There's a power good on 10. That's an output. They did not use it on this one. Pin 10 is not connected to anything. But on some of the other supplies, like the 4-pin supplies and the Slims and the Pros, that pin 10 power good is what goes back out to one of the pins of the 4-pin connector. Just looking, I'm looking over temperature. That resistance was fine. I'm looking to see, is there any other shutdowns going into this thing, going into it, not coming out? Because this chip is killing that 5 volts whenever this happens. Which means this chip, the DNP012, has to be getting the signal of something it does not like for it to make the decision. Because you swap that chip out, that should be a good chip. I do have some more of those. If it's not over temperature, like the PFC part, which the PFC voltage never really gets high enough, which may be a clue. But I'm not sure if it's just shutting down before it gets a chance to build up fully. What I was looking for, though, is how the PFC circuit, how does it convey a problem like this right here? So there's another temperature. I'm sorry, let me switch back to the other one. It's the schematic. So there's another temperature sensor over here going into this DAS001. Let me check that temperature sensor as well. I do have some of these DAS001s also. They're using the PS5 power supplies. Well, they all come from AliExpress in some way or another. But I do have some there. I just had to, my good supply here, the one I'm comparing to, I had to replace the DNP012 in it. I have 2 more of those, and the one I put in was good, so I think I've got some good chips here. But yours are probably good too. Although fake chips do exist, I don't think that's one of the ones they're faking too much. Over temperature 1. So that goes into pin 1 of that. Okay, I wonder if that's marked on the board. If that OT1 is marked on the board. Goes through a diode. It connects straight to IC51 up there. I'm just looking for a good place to check that resistance of that temperature sensor. If I can't find it, I could get on pin 5 of that IC51 up here. this one. And there's that IC. Is it not? Is it 51 or is it 61? Am I reading that? Oh, I think it's 61. I see 61. I see 61. Pin 5. 15K ohms to ground. And that's the good board. And on this board, $15K ohms. That sounds just fine. So it's not the temperature sensor, I don't believe. Let's hope it's not this chip right here, because I can't find them. Well, these things are available. I don't have any of these. The DAS2s, those are quite the mystery as far as what's in that package. Is it a diode array? I don't know what it is. It's a very strange little chip. Now these I do have. No, I'm sorry, that's not. That's the 60. I've got 1608s too. That's your PFC controller. Where is that DAS001? Right there. DAS01A. Has that been removed? It's a little bit crooked. Has that been removed for us? Let me see. I do have some. I think I see them up top there. So I'm thinking about changing out this chip. I hate to start swapping out chips, though. I really do. But if it's already been changed, no, it hasn't. Okay, DAS. Yeah. Well, no. Well, DAS01B. Thought I had DAS01As. Although I have a feeling they're probably compatible. So maybe it's a DAS01B that's used in the PS5 supplies and not the A's. Let me check that. I could have sworn it was a A. Documents. 5. Power supplies. Let me just look at one of these. Nope, it's a B. It is a DAS01B. I think they're the same chip, though. Maybe a slightly newer revision. We're going to find out. We're going to find out. Got my heat turned down a little low. This chip's been changed out or something, I think. I don't think she's glued down. Well, maybe it was. But it just looked kind of... That solder looks strange. Odd looking. Real rough texture to it. I'm going to get rid of that stuff, I think. If we can get a new chip in here. Give it a bit of a clean. Okay. Get that out of the way. I'll hang on to that chip. Make sure I didn't just change out the chip on the good one. It's over here. Trying to think what I need. I just need to, well, I need to get across these filter caps. Oh, everything keep popping loose. I've just about ruined my little grabbers here with heat. Okay. I don't really need to see the 12 volts right now. I just need to see if that, I don't know if it shuts down because I hear the relay fall out and I see the boost voltage fall down. Okay. 160. If I can jumper this. Oops. It's hard to stay on there. No, it's already latched into the shutdown mode. $360. $360. $360. I'm just thinking how it actually tries to run for like over a second and still doesn't reach 400 volts. You can hear the relay engage. That's bypassing a little. There's a surge resistor in line with the AC input, like an inrush limiter, and it bypasses it when it starts running. $360. See, here's our PFC, and I do have some of these also. $16.08. Hello. Hello from India. Let me look. It gets to be the chicken or the egg type of thing. What's shutting down first? Is the PFC shutting down first? Or is this DMP012 shutting down the 5 volt? Because it shuts everything down. Let me switch back. It shuts down everything. But it does generate output, 12 volts. Well, close to 12. Temperature sensors measure fine. Is there another shutdown that I'm not seeing? Where is this? So there's that DAS001, which is, it's a dual op amp with a reference, pin 3 reference. Pin 3, I think it's actually 2.5 volt reference. We swapped that out because it handles, looks like it says PFC control. It's handling a temperature sensor input. Our 12 volt converter. And it's trying to make 12 volts. I don't think that's the issue. The DMP012 has been changed, assuming it's good. What is this right here? So this is a divider for the AC input right here. It's where it's doing where it's checking for overvoltage. But we disabled all this when we shorted across this. Should have taken that out of play. This is where that DMP012 drives this opto isolator to shut down the 5 volts. I mean, we could disable that, but I'm not sure how that's going to help us. Hello, worms. Yeah, we're doing battle with one of these this PS4 supply. And these things are weird because of the shutdown nature of the thing. The way there's no time to sit there and measure anything. It's just click, click, and you got to figure out why did it decide so quickly to just shut down. All this seems to be where this is just the 5-volt standby. This is all good. It's just being told to turn off. The PS5s, I don't know, I guess I'm more used to that. This particular supply, I've only worked on one of them. These supplies were from like the early days of the PS4s. I worked on some of the later PS4 ones, and that's why I have some of the parts. But this is for like the original 1000 series PS4, I believe. Yeah, this is Russ's supply. And it starts to run, and then it shuts down. It actually, the boost voltage starts coming up. We've seen it hit 360, and it starts outputting 12 volts. It doesn't. I don't think it quite got to 12 volts, but I think I saw at least like 11 something. And then it goes, nope, I've got to shut down. I got a problem. If we can figure out why it's, it thinks it has a problem anyway. Which is why, like on the PS5 supply, that's why I will disable some of the shutdowns one at a time to figure out the cause. If it's not running, it's usually one of those shutdown circuits is holding it off. I just say I don't want to leave it that way, but it helps me. You kind of have to divide and conquer and figure out which circuit is telling it to shut down. So the PFC shuts down, and the 12 volt shuts down. They shut down. Ooh, I could do that. The reason they're shutting down, I mean, this chip, this DMP012, it has a, which pin is it? It has a pin going out. Command comes in on pin 1, right there, pin 7. Pin 7 is what ends up driving, opto isolator, right there, to turn on this transistor here. This is switching the supply voltage to your PFC and your 12 volt converter, that DDA001. This was his VDD. It's like 13, 14, 16 volts, I think I saw earlier. It's switching that to turn on those chips. That's how it turns them on and off by. It turns the supply on and off for them. That VDD switch. I can disable it so it's forced to run them. And that may be what we do just to help troubleshoot. Basically force it to run as long as the voltages don't go out of control. You can remove the LLC IC. Well, I guess in this model, the PFC will run by itself. That's what makes it harder on the 5s, is it's all built in one chip. Right, it's hitting about 360 before it shuts down. Shack Angel. It does start. Oh, let's see. But will it keep running? Or will the DDA, will the DMP012 say, hey, I'm not getting 12 volt output, so I'm gonna shut down? Like, do you have to force it to run, and override the disable? Why do you have to remove the high side MOSFET? If it's not being driven, it would just sit there and be open, wouldn't it? Oh, I see. You're talking about forcing it to run. I can force it to run and just monitor the voltage and see if it, like I said, I've seen it, we'll go up to 360 on this meter. Yeah, to do that, you got to enable it to run so it gets its VDD voltage. And well, I guess it'll, as soon as it gets that voltage, I mean, you could stick 16 volts in there and it would run. But well, without the input AC, it's got nothing to double. I know what you're saying. Is it the PFC or is it the 12 volt conversion, which are both trying to run? So it's strange. Neither one of them is totally dead. They start running. So as far as that's the 12 volt. I'm looking there. Yeah, you're saying. I guess you could just lift this ferrite bead, couldn't you? Just lift the ferrite bead feeding that thing. Really, glue under the resistors become conductive. Wow, hadn't seen that. So what do you think, Shack Angel? Can I just lift this ferrite bead 13, and that'll isolate the chain there, and then I could force the PFC to run and see what it builds up to. You remove the DDA 001? And then force it to run and see if the boost voltage comes up where it should. All right, let me remove that DDA 001. Although, I'm going to discharge first. I'm not sticking my fingers in this thing till we discharge it. Oh, and my meter goes to sleep. Make sure I'm getting on the right terminals here. Oh, well, and turn off the AC input voltage. I'm trying to figure out why you can't discharge that cap, because it's charging it right back up. I've done something similar to this on later supplies, not on this model. I've never really worked on this model. But I figured out that, since it's separate chips, you could run the PFC separate. And I've seen if you disable that PFC on the later ones, the 12 volt converter would still run, off the 160 volts rectified and filtered. It may not be happy about it. Maybe it's working harder than it has to, but it would still run if you did not allow the PFC. I'm trying to remember on the later supplies, there was like a fault output on the controller for the 12 volts and the controller for the PFC, and they were like paralleled. So either one of them could yank it low and cause a shutdown. And I remember going in and disabling that shutdown from each chip one at a time, lifting that leg to figure out which one was pulling the line low. All right, here's our friendly neighborhood. This is the 12 volt converter. We are discharged. Let's just take it loose. I'm going to bump my heat up to 350. 350 is about as high as I like to go on these boards. I guess I need to switch back, don't I? Yep, sorry. Yep. gotta remember to replace that jumper there. I'm gonna go ahead and take that off. You know, a big piece of wire. Where did that piece of wire go? Did I drop it? I don't like it when I have something in my tweezers and then suddenly it's not there when I go to set it to the side. I always wonder, where did it go? Where did it fall? Never a good sign. Get rid of those solder balls. Oh, there's that piece of wire. It's still stuck to my tweezers. All right. At least I know where it is now. All right, so that, no pads shorting there. And I will eliminate, where is that? Where's the MOSFETs are over here, aren't they? Another solder ball lying around. Where's that ferrite bead? What did I say it was? Ferrite bead, FB13 connected to Q3, the drain of Q3. Which one is Q3? Is it marked on this side? They could not be bothered to put printing on this side. Okay, which one is Q3? It would be the bottom one, looks like, down in there. So now it's the top one. So where's that ferrite bead? Where's the ferrite bead? Is it? Oh. Oh. Is that? That's an actual ferrite bead on the leg. I don't think I'm going to be removing that one. I think. I see. Yeah. So, no. I guess we can just lift F3 there. Yeah, can't. I was thinking it was a standalone ferrite bead, not just something slipped up on the leg or something. Actually, I don't think they put it. Yeah, they did put it on there. So, yeah, we won't be lifting that. Huh. Is that fuse 3 not feeding that line? I don't see it on the. Maybe not. No, it's not, is it? All right. I guess I just need to remove the MOSFET for safety. I'll remove it. So yeah, what we're going to attempt to do is basically disable the 12 volt circuitry and just run the PFC and see if it can put out the proper voltage. Now I'm going to have to force it to run though. If I'm not mistaken, it's not going to want to run and stay running. Because that DNP012 is going to want to shut it down. Okay, that's lifted. So, where is that control? So this chip is out. MOSFET is out. Oh yeah, that. Where's that switch? I'm gonna have to turn on that that switch. Well, let's see. Do you? Well, let's try it. Never mind. How does it shut down that 5 volt? Okay, there's the 5 volts. Well, that's the feed. Well, that's the latch input. I've still got to prevent it from killing the 5 volts. I mean, I can force the switch on up here, this. So the PFC chip will have its 16 volts or whatever. Let me go back to live. How did I get to top of live chat? I'm sorry. Hello, welcome. So what I'm going to do is try to force this on. Now you could short across right there. Yeah. You could short across right there and turn on this transistor. And the PFC should run, but I'm not sure that this DNP012 isn't going to still try to kill the 5 volts, this stuff. You know what I'm saying? So I don't know if we're going to have to defeat two things. Defeat two monsters. Okay. So right now she's not going to put out 12 volts. Let's get where we can. I definitely want to measure this boost voltage to make sure it doesn't go too high. Okay, if that will stay on there. So I plug it up, I'll get my 5 volt standby, and then I can jump across oh yeah, Jacob, that TPM error, I've had that error. And I'm afraid that's probably not a good thing. The TPM chip may have died. Oh, switch the view. Give me a moment. I'll switch it. I'm looking to see which one of these I have to jumper. Looks like it's IC55 pins 3 and 4. IC55 pins 3 and 4. Oh, I'm going to make a mess with liquid metal. IC55. Yeah, that right there. Let me check. So if I'm going to turn this on. What happened there? I don't see any voltage coming up. These leads are killing me. So what do I have there? Nothing. Yeah, 112 volts. Apparently I've got a connection problem there. Now, it must have been come off because I was like, I wasn't getting anything. Now, there's 160 volts sitting there. Now, do I have, I'm assuming on IC55 here, which is this top one here. Yeah, 16 volts. And then we have nothing. So if I jump her across that, that sends 16 volts to the PFC circuit. And it should, in theory, run. Just not sure if it's going to stay running. Yeah. Just jab a big screwdriver across there. No, I think I'll just use some tweezers or something here. What else do I have to short across there? Screwdriver it is. Very carefully. All right. All right, we're monitoring our PFC. 12 volts can't run. IC 55. Okay. What does it do here? All right, it could not shut off. It stayed running, but it only put out 300 volts. Look at that. And dropping. So it's still doing some kind of a shutdown, because I get the initial surge, 370, and then it starts bleeding off. But my 5 volts is not shutting down, right? Or did it shut down? No, it's there. It's there. I want to make sure that DMP012 wouldn't kill my 5 volts. She starts 370. And I think what it should be getting, that 1608 is trying to maintain 2.5 volts on the feedback pin. Hello, Sloth Tech. Yeah, this is his supply. I don't know what I volunteered for here. So she runs. Where is that 1608? Where is that 1608? There we go. There's the 1608. So we are forcing this chip to run. Gotcha, Shack Angel. No, I'm not sure. It has not been changed. I believe I do have some of these, though. I'm not sure it's good. But it is trying to run. It peaks up to about 370. Let me see. I'm pretty sure I do have some of these 1608s. Oh, down here under the workbench is a tub of PS4 parts. There's some DNP012s if we need those. I've got a bunch of those DDA001s. I had stocked up on those, so you can't see. I'm sorry, I've got that schematics in the way. Give me a moment. I am digging for the NCP 1608s that I hope I have. I mean, I could seal one out of another supply just for testing purposes if I have to. But I thought I had them because they're used in some of the later supplies. Nope, that's not it. That's not it. Actually, I think I bought them from Mauser. They were not from AliExpress, I don't think. $16.08. I was just in this box digging the other day, and I'm pretty sure I ran across them. No, you know, it's a 1612. I've got the 16. Let me get that schematic out of the way. 1612s are what I have. But do I not also have 1608s? Because it sounds familiar to me. Well, I'm not seeing them. The 1612 PFC is what I was thinking about. What is that? I got a bunch of DMP 12s too. I thought I had a 1608, but then again, like I said, I never really worked on these. DDA001, DDA001. That's an empty pouch. What is that? That's DMP 12s. So I may have to pull one off another board here. Which we can do. Unless it happens to be one of those resistors around it, some of the feedback. Which are rather hard to check in circuit. If it's the ones I'm thinking, because they're in the mega ohms. Okay, I went through every chip in here. So 1612s are what I had. Okay. Where to buy? A lot of them I bought from a place called Z Labs over in the UK. Oh, I'll pull parts from the working supply. It's not his. It's my working supply. Ollie, Cason's really, well, they're sticking it to us for the tariffs right now, so I hadn't ordered from them for a while. But Cason's where I got a lot of, that's where I got the first DAP 56, DNP 014s. So, 1608 here. Well, the PFC is definitely not maintaining voltage. I'm going to discharge this before I do anything stupid. Okay. All right, let me just pull that chip off of this working supply. Because we got to know. We're going to have to know if that's the issue. And I don't have a new one. Thought I did. I probably got another one of these in my box of power supplies over there. I dug this one out the other day. Didn't know I had it. Alrighty, let's get it off of there. Just add a little bit of leaded solder to it to help it, to encourage it. I'll try not to point this heat in one spot on this board. Nothing good will come from it. There we go. And right there. Yeah, that one's still glued down, isn't it? Come on. There it goes. Ah, get off there. Set it to the side. Try not to put the chip on backwards. Which way? It's that way. You can see the... I had already forgotten which way it came off, but I see the notch on the board there. Alright, now let that cool off a little. Okay. It's not going to make any difference whatsoever. Yeah. Shack Angel. You're talking about the dividers. Is it a bunch of like 2 megohms or what is it? What do they use for the divider chain? Croupier, I'm using 350. I'll use 350 max on these boards. And like I said, don't point it at, don't go right at the IC and just sit there. Keep it moving. Keep it moving. Use flux, add a little leaded salt just so you can kind of minimize the amount of time. And I've gotten pretty good at not popcorning them. You just can't put the heat on and just sit there. You got to keep it moving and minimize as best you can. All right, I'm going to force this thing to run again. See what happens. She's cool off a little there. 160. Okay. Oh, bad glare there. Sorry. Trying to get rid of this atrocious glare. Okay. Going to force it to run. Shorten across IC 55, pins 3 and 4. No. $360, exact same, does the exact same thing, goes up to about 360, no, 380 that time, and shuts down. So are we thinking resistors? Turn that off, and I need to remember to discharge that. Let's look at those resistors. Make sure I know which ones you're talking about. You're talking about the divider chain for the feedback. Where is that? Oh, I'm staring at it here. Okay, these right here, I would guess. These 2.7 megs. 2.7, 2.7, 2.7, and the 51K to ground. Yeah, you can't measure these things in circuit. I bet I don't have any 2.7s. Yeah, we're trying to divide and conquer, Russ. We're trying to decide, is it the 12-volt circuit that's shutting it down or the PFC circuit? They both start at the same time, and they're both kind of shutting down at the same time. So right now we've disabled the 12-volt circuit. That we've removed that DDA001, which drives the 12-volt MOSFETs, all that. And we're just trying to get the PFC to stay up and run and regulate 400 volts. So I wonder why it's shutting down. Is it because I looked at the specs for this chip? I know it's trying to maintain 2.5 volts on pin 1. That's what it's trying to maintain. If it can't, it's probably going to get very unhappy. Because if you do the math on this, if this is 400 volts, this will divide down with this 51K to ground. You get exactly 2.50 volts on pin 1. But what's frustrating is it doesn't give much time at all for that to get there. And then it goes, nope, I'm not happy, I'm shutting off. So you think it's just resistors, Shack Angel? I know I don't have any 2.7. We can lift them, measure them, scrape the glue off of them like you're saying. I've never seen that. I've never seen them that sensitive to the glue. R25, R24, R23. Most popular resistors, will it shut down like that? All right, well, let's lift them. Of course, once I lift them, it may change the resistive reading, I guess. Let's lift them and see if any of them measure weird. Because when I lift them, I'm going to break that glue seal underneath there. Let me discharge this. Because just like in the zombie movies, don't get bit. Okay, we're down to 2.5 volts. 23, 24, and 25. That's odd. 23, 24, and 25. We got to locate those. And of course, they're connecting in to pin 1 of that 1608, so we can just kind of follow back from there. Because I don't know where they are. Pin 1 is here. So I see a capacitor. There's that 51K resistor. Is it pin 1? Pin 1. Is it coming from underneath? Because what I'm seeing is a resistor going to ground. So it must be coming from underneath over here somewhere. That's not them. 18, 19, 20. Oh, here we go. I see them. I see them. There they are. All right, let me see if we can. I need to lift these without breaking them, because I don't think I have any 2.7s. Not that size anyway, and that precision. The ones I buy for the PS5 supplies are, I think they're at least 1%. You think about the 1% at that big of a resistance. I can't remember what I bought for these, for the PS5 supplies. I know they're not cheap at all. I think they're like $1 each or something for those resistors. Not cheap at all. Trying to get my tweezers in there where I can break it loose. There, that one came loose. I'll just set it off the board here. Okay. And of course, yeah, they got glue on the back of them now, don't they? Unless it broke off. Which it may have. Let's see, what do we get? Can we get on these big things here? I have to get my tweezers out. 2.69. Oops. Sorry, I'm slipping. .693. They're a little bit warm right now too. 2.699. 2.691. 2.694. That one there is the best one of all of them. So do we have some glue on the back? A little. A little. Not really any on that one. That one's pretty clean. Of course, there's still glue on the board. That could be causing some trouble between the pads there. We'll get rid of that. We'll clean these up a little too. Have codes on them. Oh, the 1% ones? I thought it was these. Where are those 1% ones though? Where are they in the circuit? So they have codes on them and not just regular markings. Is that around the 1608s? I see some 1BC. I see 61C, 18C. Is that the ones you're talking about? So I'm going to clean these up and put them back on there. But you're saying you think it could be the ones with the EIA 96 codes on it. I'm going to flip one of these into the floor. Oh, yeah. I'm about to lose the one that stuck to my finger here. I'll get rid of this glue. And we'll clean them up and put them back on there. Okay. Where did they go? Right in there. So those big ones weren't the ones you're talking about, huh? Yeah, the ones with the codes. Okay. I have to look up those codes. Actually, it may be on the schematic there. Let me clean these up, though. I'll get rid of this stuff. And I'll use the grinding pen on it. think I got most of it there. Okay, let's put them back. A lot of solder on the end of that one. Let me get rid of it there. Okay. Should we try it now? I realize those are may not be the resistors in question. What are you talking about? That? That's not really a via. This is a kind of a single-sided board, so probably should get all that flux out of there. We'll give it a try, and then we'll take a look at these resistors here, which I'm going to have to look up the codes for. I'd like to see where they are in the circuit, too. Alright, our 2.7 meg resistors are back in there. Get that off there. Wake up meter. So, okay, if I do that, 160 volts. And if we short IC 55, nope, 300 volts. 370 and shut down. 380 that time. But she won't maintain. Steadily bleeding off, kind of acting weird. Let me discharge that. Okay. So, well, yeah, I see the point you're talking about, but it's part of the trace there. See what I mean? It's part of it. It's part of that trace. Can you see it there? Yeah. Okay, so these other resistors, 61C, 18C. Okay, there's two 18Cs there. What is 18C? Just a moment. I've got that bookmarked somewhere. EIA 96 resistor codes. Mm. 18C, 15K ohms. 15K ohms. I hadn't been smoking much here lately. I've been grilling some steaks, but that's about it. Aren't these two 18Cs? I think what I want to do is just, we're going to lift those and like slide them to one side. Keep them on the board so we can measure them without them running away. The fuzz off the tweezers. Park that right about there. Stay there. And I will park you about there. And we'll park you right there. So 18C is supposed to be 15K ohms. 1502. 1505. I haven't looked up 61C yet. 42.17. Hello, Chlor Slug. 61C, I think it was, is supposed to be 42.2 K ohms. .16. That's pretty darn good. 15032 and 15 exactly. 15028. And you think these are 1% resistors? $15,027. Is that a little? All right, what is 1% of 15,000? Probably 15 times 0.001 or something like that. Times 0.001, that should be like 15 ohms. If that's right, I think it should be within 15 ohms. It's a tad out. That one is pretty darn good there now. Or am I calculating that wrong? Let me think a second. That's 150 ohms. I was calculating 0.1%. I was a decimal point off. 1% of 15,000 is only 150, so that means those resistors are just fine. They are just fine. Yeah, 150 ohms. I just Sloth Tech. Well, thank you, Sloth Tech. I just now my chat window was like stuck. I hadn't scrolled down. Thank you very much, Sloth Tech. That's very kind of you. So yeah, 150 ohms. Those are fine, unless they were they were off because of the glue before I broke them loose from the board. They're well within these two are well within tolerance. 61C on this one, 42,135. And what was 61C? We decided 42.2. So 1% of that is probably 420 ohms. So we are probably just fine on all these things. So we still don't know. Oh, let me get my chat window back. Like I said, unless they were bothered by the glue underneath them, and then I broke it loose. We're running out of options here. I did not check the 51K to ground. Actually, resistors, yeah, these resistors are over here on that DAS01B, which is part of the PFC control, apparently. Let me clean that mess up a little there. And put those back down. Still can't get all that glue out of there. Oops, where'd you go? I'm stuck in there. That one came right off. Let's see if we can get them back on there. Sit down on there. And how about you? And you right there. Well, those all looked pretty good. Yeah, I did not check. Oh, there's a precision. That 44C right there. R92. It's not even in that circuit though, is it? Looks like it's connected to this MOSFET over here. 44C. Alright, well, I cleaned out behind those. I don't think that's going to make any difference. But we'll try it. See what happens. And short IC55. I'm not getting a good reading. Yeah. Negative terminal popped off again. There we go. $360. $380 if I like pulse it there. And then it dies off. Dies off slowly. But I guess in theory it's still running. Or maybe not. Maybe it's just bleeding off at this point. Sure seems like it's not still running. Like it's still doing a shutdown. And I could probably check that with a scope. It still acts like it's shutting down. Like it starts to initially run and then just shuts off. Is Russ streaming later? Oh, well, my window is like way behind or something, huh? Okay. Where to go next? There's a whole lot of chatting going on in chat. A whole lot of excessive chatting. This 1608 we changed out. What is this doing right here? What are you doing? And can we make you stop doing it? NTP 1608. Let me look at the data sheet for this thing. Because I don't remember if that has to go high or low to be a shutdown. Let me change this to that. And I turned that off and that on. That didn't quite fit on the page. What the heck? Does not fit on the page. If I close that. Oh, I guess the window is, the window is too big, or, sorry. That's what I was trying to do. So, pin 2, the control pin of this thing. Well, it looks like you can't leave it floating. See here, they just stuck a capacitor on there, it looks like. Pin 2, control pin is the output of the internal amplifier. Constant is negative between the control pin and the ground. But they seem to be just, okay, now there's a capacitor. Yeah, I see the capacitor. So what happens, I guess, when you pull that to ground, it must be a shut-off. It doesn't tell you that here in the notes. So. Yeah, it doesn't say it. But I'm going to guess pulling pin 2 to ground tells it to shut off. Because they sure, they connected a MOSFET to it to ground. Usually they mention it in the data sheet. They'll tell you that's what they're doing. Because like you see on here, they've connected it, it still needs this RC network on there, I would imagine. But they've got this MOSFET on there to pull it down to ground. I'm going to lift that thing. I'm going to lift that Q73. I'm going to lift that. See what that does. I'll turn off the power. I'm going to discharge this thing. Where is that? Q73. You're connected to pin 2 of this IC. Oh, there you are right there. You're not hiding at all, are you? So it's connected directly to, oh, wake up meter. You're connected directly to pin 2. Is it here? There, okay. You're connected there. Okay. So that's where I'm going to lift that. Try to make sure I've got that cleared. I think I do. Not connected back there anywhere. Make absolutely sure you're not connected to pin 2 anymore. You're not. The pad is, but you are not. Okay. Okay, that's lifted. Let's find out what you do. All right, my leads have come loose again. It's always one of them. You stay there. You go right there. Now, that's not that hard. All right, so 160 volts. IC 55. No, wrong chip. She's still shutting down. She is still shutting down. Next time we check the actual PFC MOSFET and diode. Those rarely fail. Yeah, I would have thought they would have. I've seen one do a weird partial leakage to gate before. Not in this model supply. So I lifted that. What else is in here? Let me switch back to the schematic a second. Let me refresh my chat window because it's not, man, it's like way behind. Oh, well, that's better. Drive. I have not put a scope on it, but it just acts like it just stops running. Lifted this, so that can't be disabling it. Lifted the drain of this MOSFET. You got some RC networks here. You got some capacitance. Now I have not checked. I'm assuming our 16 volt VDD is not going away, is it? I should probably confirm that. You know, is it losing its supply voltage? And that was on, oh, let me switch back. That was on pin 8. Pin 8. pin 8, which is right here. Nothing there right now, of course. But if I turn the power back on, okay, and if I jumper, I'm on pin 8, I'm trying to make sure I'm on the right ground here. And if I jumper that, it's only 8.6. 8.6. I am on the right ground, right? Why are you 8.6? Oops, I keep jumping the wrong one. Slipped. 8.6. Oh yeah, Jeffy, I didn't find something in a few seconds. I did not. I was trying to, I was hoping it was another shutdown, this other MOSFET, but it was not. Now, this VDD supply is only 8 volts right now. Why is that? What does this thing need to run? What does it need to run? Like, what's its minimum? Supply voltage. Oh, well, their ratings minus 0.3 to 20. So it's got a wide range. But the startup typical is 12. Minimal operating 9.5. So she needs to 12 to start. It needs to stay to 9.5 to keep running. Do we just have a freaking bad capacitor on the VDD supply and it's dropping down? Can't be that simple, can it? Can't be that simple. Yeah, on pin 8, I get 8 volts there when it starts up. Little tiny cap there. There's some larger caps on that line. I thought you checked all these caps though, didn't you? Right here's the supply. Where is its, oh, it just says VDD. So we still don't see the larger filter caps on it. And what is generating that? Is that off of the PFC itself? That can't work. What is that? Sorry, my phone's going off over here. Like to see more struggle? It needs a 16 volts, if I remember. Yeah, 16 volts is what it was running, but it seems like it drops. I'm sorry. You need more struggle? The struggle is real. This may get to be so bad I send it to Andy. You know, it's serious when you send it to... because he is slushy machine rated. Not forklift rated, but slushy machine rated. I'm looking for where that supply comes from, and I have been known to manually feed in, 15, 16 volts in there and see if it stays running. I could do that. I hate how this schematic is drawn. It is so hard to follow. Where does it come from? Where does this VDD come from? I see where it's switched here, but it's got to come off of a transformer somewhere. Where does it come from? And I can't search it. There's VDD. Where does it come from? That's the grounding, ferrite beads and the grounding, you know, that kind of stuff. I want to know where this comes from. Because I want to know where the capacitors are for it. VDD switch 1. Okay, this is the 5-volt circuit. Oh, you think it's an auxiliary? That's what I was looking for. Is it an auxiliary winding off the 5-volt? Here's the 5-volt circuit. That's the 5-volt output, so it's on this side of it. There's a fuse. Shouldn't there be a diode here somewhere? Rectifying it if it's off of this? See, it shows it coming in up here. So this is the 5-volt. It does show a winding here. No, that's the drive out. This thing has a built-in, you know, driving MOSFET to drive this. No, there's no auxiliary winding off this thing. Nah, it's not that bad. It's not possessed. This is one of these things that once you go through this struggle and figure this out, the next ones are just easy. Because this makes you dig into this schematic and figure out what goes where. But this VDD, I'm hoping it's not off the 12-volt circuit, is it? Because that's kind of a problem. Like, is it a the way this is laid out just killed me. It has to be on the hot side of it because the 1608 is on the hot side of it, the AC input side of it. So it has to be on that. This is the 12-volt generating stuff. So is it just like a resistor divider? You know what I'm saying? That generates just 16 volts? Because I don't see a winding coming off the 5. I guess I can find this transistor. I think it's the only one like it. I can find it and just follow the damn thing back. Where are you coming from? I want to know where this VDD comes from. Because it seems to be sagging mightily. Down below the run voltage of that 1608. And that would make a lot of sense to why it would start and then fall over. But am I missing something here? It's not here. This is the cold side of the board. VDD switched. That's a high voltage startup divider here, I believe. No, it's at DAS001. VDD switched. Where does VDD come from? 12-volt filtering. Here's your main AC input. HVSB plus. So that's your 160. Let me confirm that. Like if I don't turn this thing on, wake up. Where is that VDD switch? What is its part number? What's its part location number? I can't find anything on the schematic. It's so not laid out like I would lay it out. It's like random. I'm just going to find that thing because I want to make sure it is 16 volts. I think I saw it earlier. It's 16 volts, and then before any kind of load on it, it's 16 volts. I've only done, I didn't make this schematic, the croupier. I've only done PS5s. I did not make this PS4 schematic at all. Q41. Q41 is what we're looking for. Q41. And my lead popped off. I heard it there. Q41 is just a little bipolar transistor. '31. And it should be on the hot side of this board. Need to remember I lifted that one. Where the heck is this thing? It's not a through-hole component, is it? Where is Q41? This thing's going to make me follow pin 8 all the way back to wherever this supply comes from. Q31. Ah ha ha ha, there you are. There you are. So when it's not running right here, what kind of voltage do you have? You have 16 volts on you. Okay. All well and good. So if I measure that, and then I short and turn on this IC55 over here, right up here, 10 volts. And that's on one side. What is this up here? 0. Is this after the switch right here? Yeah, it's only 8 volts after it's switched. This is into the switch, and this is out of it. It's only 8 volts there. So this right here, 16 drops to 10. All right. Where is the filter cap for you? Where do you come from? You should go back there, wherever you came from. I'm just following these traces with my eyes. I see them going to several of these auto isolators, but that's not the source of it, I don't think. There's got to be some some capacitance here somewhere. $16 there. Is that AC right there? There's a 2 ohm resistor right here. So what are you? Not quite understanding that. 16 ohm, 16 volts, and a half a volt. It shows a jumper there. Huh? Maybe I'm insane. 16 volts here, half a volt there. Is that a jumper? It looks like a jumper. All right, I'm going to turn this off and see what's on the other side of this board right here. It's not marked as a jumper, though. No, I don't see no jumper. What is that? D21? Oh, there's a diode there. Or am I looking at the wrong thing? There's a diode there. So we're talking about right here, between those 2 points. And if I flip it over, D21 is right there. I know these capacitors are charged too. I'm not going to grab them. D21. Yeah, we got some voltage there. We got a little voltage there. 16 volts. Sitting there holding 16 volts and it's turned off. D21. Oh, looks like I got a package at the front door. I hope it's not another cursed power supply. Oh, who's been console crafter? Console Crafters 813. Well, thank you. That's very, very kind of you, sir. Very, very kind. Thank you so much. You gifted 10 memberships. Rusty sent me 10 more power supplies. I'm going to send Rusty back something that's ticking. D21. I think we're on to something here. I need to see the source for this VDD though. And it's right here in front of me. Because what I could do is I can insert 15, 16 volts from a bench power supply and see if it maintains the run. Because sometimes, there's a circuit to help it get started. That's the only way I have right now, TJ Miller. That's the or T, I'm not trying to pronounce it. That's the only way I have. I haven't set up any kind of donations or anything like that. Wasn't really looking for donations. We're just having some fun. But you know what I mean? Sometimes there is circuitry to provide enough voltage to start it, and then a secondary run voltage has to kick in and start generating voltage to maintain it. And I'm not sure if that's what's happening on this because I can't find the stupid circuitry on this horrible schematic. Because it just jumps everywhere and just says VDD. You figure out where it comes from. That's on you. You figure out where that comes from. But it doesn't seem to be a secondary off the... Oh, wait a minute. Right there. Right there. There's D21. It's a secondary voltage off the PFC circuit? No, it is the 5 volts. I'm sorry. That's the 5 volts. It is a secondary off the 5 volts. So the 5 volts is running. I didn't see it earlier. It's right there. It's plain sight. So there's your circuitry. But it seems like it's getting loaded down. So either it goes through a 0 ohm, it goes through a 2 ohm. Where's the capacitance though? You know what I'm saying? You're rectifying it. There should be some filtering out here. Yep, it is T1. So this is it. It is off of the 5 volt generator. So in theory, it should be there at all times. Oh, did Pico say it? I apologize. Well, thank you, Pico. I'm sorry I'm not very good at watching the chat. Because I did not see it. Or I looked in this area, I just didn't see it. Where it said VDD. And it wasn't until I saw D21 and realized, oh, I just looked at D21. It had 16 volts on it. But it's dropping down to 10. So where's its filtering? So yeah, I don't like how this is drawn. It doesn't show the filtering right here. Like it really should be. 56 picofarad, that's not going to help us. I'm sorry, that's not going to do anything for us. There should be a couple hundred microfarad or something there nearby. Otherwise, it's just going to fall over in a hurry. So here's the switching for it here, and they don't show any filtering. Oh, you need to load the 5 volts? So if the 5 volts isn't loaded, it won't run hard enough to generate the other voltage. That doesn't make sense. These other supplies work. The voltage will be lower. So I'm saying these other supplies we have will work without a load on the 5 volts. I've got one here that'll run without an additional load on the 5 volts. But I can see it being lower though, because it's going to be generated off that same winding. But it should run without a 5 volt load. I'm sure the voltage will be higher though. So is it not running though because of a capacitor that's, you know, not doing what it should do? I see some capacitors right there. It looks like you've already taken them off and checked them. C25 and C26. This thing's still going to have some charged caps on it. C25 is 100 microfarad at 50. C26 is a 4.7 at 50. Oh. All right, let me run to the restroom just a moment. C25? Yeah, C25, C26. I'll be right back. Give me a moment. Did anyone fix this while I was away? But I know what he's saying, what Shack Angel is saying. It's just a secondary winding off the 5-volt generator. It's not regulated. You know what I'm saying? Like, this thing is running and driving this transformer to maintain 5 volts out here through the feedback. This is just whatever it is. You know, whatever gets generated as a side effect of the driving of this primary winding. And it'll vary. But like I said, the other ones we have will run without a 5-volt load. But like if we load the 5 volts, this will drive harder, and this voltage here will come up along with it, because they're not attempting to regulate it. So what I can do is I could inject, 15, 16 volts, just to confirm that the PFC will stay up and run then. Just to confirm that. Make sure we're not barking up the wrong tree here. And if it does, then we know that's what's happening, is that rail is dropping below the point where the PFC can run. A Zener on VDD. Yeah, did I see one earlier? Let me find a diode. Give me a moment. Let me find a diode, because I don't like to, inject, in parallel with that other rail on board without some isolation. Where's my diodes? So what I like to do is I'll do it through just a little silicon diode. If I can find one here. I'll connect my bench supply. I'm going through parts bins. I know I have just some. I just need a garden variety rectifier. Nothing special. We're not going to be. Doesn't have to be fast switching. I don't need a lot of current. I do need to label these drawers so I can find this stupid thing. Here we go. Some of these are labeled. I'll take a 1N400. Oh, what's this? What is this? 5817. I think that's a Schottky. What is a 1N5817? Is that a Schottky rectifier? I don't really need Schottky, but I'll take it. 1N5817. Yeah, 1 amp, 20 volt Schottky barrier diode. Running a little closer than I would like on the voltage there, since I'm going to be putting 16 volts in there. What other options do I have here? What are you? I have a bunch of them, so let me see. This is just a garden variety rectifier. 1N4004, is it? $4,004. I'll take it. So what I'm going to do is make sure these caps are discharged before I do something unfortunate. Yep. I'm going to fire up the bench supply, set it for about 15 volts. And I would not feel good about doing this if I did not have, this plugged into an isolation transformer. Because you can get some weird, you know, grounding going on. You don't want weird paths. You don't want to happen. So, but I am going through an isolated transformer here. So let me get my leads. I'm going to crank this supply up to 15 volts. I don't think I need more than a couple hundred milliamps though. Something like that. And what I'm going to do, yeah, I'm going to connect this diode right at that, wherever that D21 was. I can find it, then I can't find it. Where are you? It's right in the middle of the board. Yeah, it's right here. It's right on those pads right there we were looking at earlier. D21. So if I get on the cathode of D21, which is toward the inside of the board, and I solder a little wire. It's right here. Okay. Oops, don't break the lead off right away. We're going to get where we can monitor our PFC voltage. Okay. My leads. So this is where it gets big dicey here. You need the isolation because I'm about to connect the ground of my bench power supply to, you know, potentially one side of the AC line right here, which is why we have the isolation transformer. And then I'm going to connect this here. Right. Yes. All right, I'm going to turn, let's see. Yeah, turn that on. It shouldn't run. Like if I turn this on, in theory we should have, you know, 16 volts sitting right here right now because she's, you know, nothing is drawing off of it. Then I'm going to turn on my bench supply, which is set for 15. So basically we've got 16 here, 15 here, negative 15. Oh, well, my leads are reversed. That's nice because I was driving the DC motor the other day, helping my son work on something. Door locks for his truck. And that's why I was reversing my leads to reverse the voltage. That's not good. All right, now we should have 15 volts, 16 volts. So basically this is doing nothing right now. The diode's got it isolated, but we go to turn it on. If it were to sag, you know, below, you know, 15 volts, it should, my bench supply should pick up and take over. Oh, let me see if I can, you can see I've got it sit down there. Drawing no current right now. So 160 volts, and if I turn this on by shorting IC55, in theory it should run 420 volts. And I'm drawing 20 milliamps off my bench supply. Well, my leads, my screwdriver's slipping. We're regulating 400 volts, drawing 32 milliamps. So the PFC will run if you give it enough voltage. That's encouraging. But this onboard supply has just fallen on its face. Okay, so that's why I wanted to do that. That tells me that PFC will work just fine if you give it enough voltage. That makes sense to everybody? Just need to run it like that, you think? We could do that. All right, so that looked good. That went to 400 volts. Everybody still hanging with me? Everybody know what's going on? Why I did that? Oh. Does that all make sense? Okay. Yeah, what I'm doing was rather dangerous without isolation transformer, because you don't want to get your grounds, and same thing happens with scopes. You end up trying to short out your local power company and nothing ends very well. If you're lucky, you just trip a breaker or you burn off the ground lead to your scope, which I have done that, not in a few years though. What I was doing was substituting my bench supply for the onboard supply that runs that power factor corrector. It needs 12 volts to start, 8 or 9 volts or something to keep running. And our onboard supply was just sagging whenever it would start up. There was enough to start, and then it would like fall down below 10 volts or something, 8 volts. And that's why it was shutting off. So I injected this through a diode so that when the onboard supply fell and couldn't maintain it, that my bench supply would then feed through this diode. But I did not want the onboard feeding back into my power supply or anything like that. That's what the diode's there for, to keep the onboard from trying to feed back into my bench supply. I just wanted my bench supply to be able to take over when needed, and it did. And it's happy days. I think we're on a trail of something here now. We're going to discharge this. We're going to look real close at those capacitors you checked, Russ. You mentioned Finercy. Be sure to spit when you say Finercy. Some of their stuff I don't mind. Like I've got the USB-C, analyzer thing. That's pretty neat. This thing, that's kind of neat, because you can check power supplies. You can plug a power supply in, and you can go through this thing, and you can tell it, give me 9, give me 12, give me 15, 20. You know what I'm saying? It'll give commands to your supply. So it's pretty neat for that. But their scopes, if you ever look at the reviews on their scopes, they sometimes kind of stretch the truth a little about their specs. A little? Oh. Turn off the AC input. So that's the basic problem, is that 16 volt rail, which I couldn't remember how it was generated, is not staying up. I think we're through with our 1N4004, which is just a very common garden variety diode. Not a fast switching diode. It's like a low speed rectification diode. So C25 and C26, it looks like. I didn't find them on the schematic, I don't think, but they're right there by this diode. You know what I'm saying? There's the diode, there's the capacitor, so I'm going to guess that is them. Let's take them out and check them. It may not be the problem. C25, 100 microfarad at 50. if we can check that. What am I set to? I am set to check inductance. So let me change that. I want capacitance. Set for 10 kilohertz speed. I want capacitance and I want ESR. Okay. What do we have? What do we have? 92, that's not bad. 92 microfarad, 0.03 series resistance. That's a pretty good capacitor. I don't think that's the problem. I don't believe that's the problem. I don't think it's that critical. I was checking at 10 kilohertz too. I bought this thing used off eBay a long time ago. The brand is Applant. They make some decent stuff. It's got an internal rechargeable battery. Of course, you can plug things. You can plug leads into it, or it comes with this little breakout device here that gives you can make like a 4-wire. Like if you're checking precision resistances, it'll do 4-wire measurements. But I got it for checking like ESR and stuff like that because I didn't have anything decent. I don't remember how much I paid for it. It's probably a couple $100 or something. I bought it used years ago, and it's an older unit. I think that they replaced it with a modern one that goes a little bit. It's useful sometimes, like on that thing will check on different frequencies. Most cheap, capacitance meters, whatever, only use one frequency, and this one can go between 100 hertz and 10 kilohertz. And some of the newer ones will check up to 100 kilohertz. Because like really big filter caps, or you usually want to check on like a low frequency. You want to check on a frequency that they're actually going to be used at. And so that's why it has the 100 hertz range, close to 60 and 50 hertz. You can just get more accurate readings on these big capacitors like that. So that wasn't bad. What's the deal then? It was drawing 30 milliamps. I'll check this small one. I'm not really sure if this small one's in the circuit or not. I should probably look and see. There's D21. It's got to be. So I've got a C25 and C26. C25 is the one I just took out, 100 microfarad. C26, I was going to see if it's even in the same circuit. There was C25 right here across these points. Where's C26? It's right here. So it's the main filter cap. What is C25 even doing? Because here's the diode. It would have to be after the diode. Okay, now I take that back. I see what they're doing. Diode. I remember it listed this. Here's the diode. Here's our diode. 2 ohm resistor. There's your big capacitor to ground, 100 microfarad. So this is a different. This is D22. This is a different diode. Which one was it in the? The schematic says D21. I'm not sure what D22 is. I see it over there. I see it. I see. I do see that Zener. It's a 24 volt Zener. But it didn't seem like it was breaking down though, because my power supply did not. Let me switch to the schematic a second. Hope I'm not boring you guys. There's D22. So there's C25, 100 microfarad. There's D22. Then there's C26, 4.7. There's some, 1,000 nanofarads, whatever. Zener. And then I guess it's just through the switch. I wonder. I'm guessing that thing, this C25 measured like 90 microfarad. I am wondering, what are the chances that this capacitor has lost just enough of its capacitance so that it won't stay running without a load. Like I said, if I put a load on this 5-volt supply out here, which it would normally be running the chassis, this thing would run harder, and you'd have higher voltage out here, and you could be more forgiving of what's going on here. Anyway, let's check this 4.7. But I would have thought that it measured like 91 microfarad. I mean, it's a little off, but I expected it to just be open. Let's check this other one. I'd just be surprised. I need to check that resistor to make sure it hasn't opened up a little. That 2 ohm resistor. We're probably not that lucky. Not that lucky. Where is my... See, that's supposed to be 4.7. That's a little low. .8. I just don't think it's enough. Do I have 100? Let me see if I have 100. I would just be very surprised if that's enough of a change in capacitance. If it is, they were living on the edge with that one. I got a 470, but that's at 16. We don't want to do that. What are you? Here's a 220 at 35. Well, that would do it. I'd rather put the right thing in there, though. I used to have some hundreds. I know I did. What is in this? Just digging through my parts bins. What is this over here? This is a... I can't read it. Need a little more light. Uh, 22 at 50. Do I own any 100 microfarads? There's a 1 at 50. What are you? There's a 10 at 50. It's not really what I need, though, is it? Can never find the caps I need. This is a 220. Been laying on the shelf for a while. See, it only measures 150. I'm checking at 10 kilohertz though. Which, I mean, this thing isn't running at 60. I'm not sure what frequency that converter runs at. I would think it'd have been at least 10 kilohertz. That little DNP015. What if I change this to 1 kilohertz? Measure 178. Now this, I'm sorry, you're on the, I left you on the schematic there. I was going to look and see. D22 is in line. So we rectify it over here, right here. We go through a 2 ohm resistor. It looks like some things are powered right there. And then, like this is after another diode, this converter. But there's a 100 mic and a 4.7. I would think that 100 mic is going to be your... All right, let me replace this with what I have. I have missed lunch. Approaching hangry. Okay. What I have is a 220 at 50. I want to pop in there. And I'm going to put this 4.7 back in there. I guess I can clip these leads. I'm not going to leave it in there, I don't think. But okay. All right, what does it do now that we've swapped those? I need to be on this side, don't I? It's good to know you can run this PFC separately. That's handy. Very, very handy. Let me switch back. You can't see Russ. So I replaced it 100 with a 220, and I put the 4.7 back in there. We're going to see if, no bench supply, we're going to see if it can stand on its own here. 160, and then if I start this up, no, it fell again. It fell again. It fell right over. Where'd my clip lead go? Oh, in the floor. So that voltage still fell down. Like if we're measuring it on, yeah, it's pin 8. What? Oh, there's nothing there because it's not running right now. That's right. I was trying to find it on pin 8 and it's not going to be there because we haven't turned it on. But if I check like right across this capacitor, there's that 16 volts. How far is that dropping when I engage this? Down to 10 volts. $10. What is on the other side of this 2.2 ohm resistor? 10 volts and 10 volts. We're not losing anything appreciably across that 2 ohm resistor. So that's not the issue. What do we have? That's 15. 9.4. I'm checking across this other small diode, D22, which that feeds into the PFC IC. I mean, it feeds into the DMP015. And it seems to be happy as it can be. It's pulling it down to 10 volts. And after the switch, the transistor that's switching it out over there, it's only 8.5. It's 10 volts going into this transistor over here. Now, my screwdriver is slipping. There we go. Get on there. 10 volts, 8.5, 9.128. Let me look at that. This is very interesting. Where is that? And it's loading it down. It's loading it down. Oh, what you can't see? T1. I don't really have any way of checking T1 unless I swapped it. You do have some, there's a 0 ohm jumper there. It's probably a wire, so it's not likely to fail. What about D21? Not likely. I feel like we're close though, Russ. I do feel like we're close. I do. Because one thing I have not tried is like Shack Angel suggested, putting a load on the 5 volts, which would in turn make this thing run harder. It would drive T1 harder, and you get more output voltage. But I don't think you should have to do that. I wish I knew. It only drew 30 milliamps off my bench supply, which doesn't sound like too much, but I don't know. I'm trying to figure out is something. What is the this VDD goes to a lot of places. The 16 volts is going to a lot of places. Is something else loading it down? I'm trying to see how much the current supply should be. Maximum supply current plus or minus 20 milliamps. Okay. That's the supply of the 1608. It needs 20 milliamps, approximately. But this supply has to be able to power the PFC, the 1608 chip, the PFC, and that DDA001. Has to supply both of them. And the DDA001 is not even in the board right now. So, yeah. So why is that? Like I said, I could put a load on the 5 volts. Let's just see what happens if I do that. Instead of talking about it, I'll just use my yeah, I know it's still hot right now. Turn it off. Capacitors are still charged though. I'm going to use my DC bench supply here, my DC load, to give us a little bit of a load on the 5 volts. I don't know how much. Maybe 100 milliamps. What do you think? Just so our 5 volts has some load on it. We're going to see the effect on this output voltage. Now, where's the 5 volts? Yep, she is still charged right now, so I'm going to want to make sure I'm on the right end of it here. Which one? There went my ground lead. Which one is 5 volts? Or which two? It actually goes to 2 pins. It's just down here on the end. Right there with that nice solder ball in between them. Been meaning to get that thing out of there. It's stuck. I think I got it. Yeah. Okay. So if I clip this load, I have a real good place to get a hold of it though. Actually I can get over, there's a coil right over here that's in that circuit. All right, now there's a 100 milliamp load on that 5 volts out now. So if I flip this, we're drawing, we got 4.7 volts. You can see that there, 100 milliamps. So now, what is our voltage doing now? Now that we've given it a little bit of a load on the 5 volt output. Like here's that big capacitor C25, 20 volts. Now we got 20 volts. So now what does it do if we engage the PFC circuit? It runs 400 volts and runs. Now, Shack Angel did say this thing needed a load on it, although the other ones don't. That's what's weird to me. Let's see if I can get on that again. So it will run right now, since I've got a load on the 5 volt output, which it would if it was sitting in a chassis connected to a PS4, it would run. You know what I'm saying? It would work in theory. It just won't work out of it. So what is that voltage now? 16.7 volts. Now that it has a load on it. Now that the 5 volts is loaded and it's driving T1 harder, you end up with 20 volts unloaded, 16 volts once you engage the PFC circuit. Yeah, she's running fine. 400 volts locked in there and running. Sorry, may have a glare on the 400 volts merely by putting a load on the output. So is there anything wrong with the supply? It seems like there is something. Something's a little bit off. Yeah, Shack Angel, he was probably right. I mean, it will work. So was there ever anything wrong with the supply? I think it should run out of the chassis. But then again, I don't know that. Yeah, with a 100 milliamp load on that 5 volts, she'll start and run just fine. So yeah, is there anything wrong with it? Like, is this like my board, my working board here? It will start without it. Is it different in any way? No, it's got the same filter caps, 100 microfarad, 4.7. It has the exact same values. All right, this is a 240 ARAA. Let me turn this off. What is this? Same thing, 240 ARAA. So if we look at, this has got charged caps on it. I need to discharge them the good way and not the bad way through my fingers. I don't think I'm making contact there. Well, they've already discharged. Okay. I'm just kind of curious on this one that does work and doesn't seem to need a load, what that voltage is. You know what I'm saying? That 16 volts VDD, what does it do? What makes it special? What did I hit there? Oh, here's my leads. I was looking for these leads laying right there in front of me. So, have we been chasing a ghost? Possibly. It does seem like though something has changed just enough. This is getting frustrating. Trying to get those clips in there. Stay there. Because I want to see when the voltage comes up. I don't have anything hooked to the 12 volts. So, wake up, meter. I don't need you right now. I do need this. And, well, yeah, I just want to see what it... We're just going to enable it the regular way. All right, should get our 160 or so here. Now my leads are reversed. Oh well. One big glare. So what is this voltage right now? Let me find that capacitor. I can't find it. And my leads popped loose. Go away. There's that capacitor. I haven't soldered on this board though, so everything is like pristine. I can't really tell. 16.34. My leads came loose, so I'm going to enable it the regular way, since I do have the 12 volt circuitry in here. Everything's in. If I do this, oh, that looked like it. Well, is she running? No. Doesn't seem to shut down. What did I do wrong? This one's shutting down. Did I steal a part out of? Oh, I did. I stole the PFC out of this one. I stole the PFC 1608 IC out of this one. I did. I stole it out of there. That would explain that. All right, let me discharge it here. Okay, that's discharged. I'm going to put the one I took out of Russ's supply. Just pop it in there. Sit down. Okay. Now she should run. That was a little confusing. Why won't it run? Because you ripped its heart out. All right. Try to let that cool off just a little. All right, so now, in theory, assuming I put that in the right way, hope I did. Yeah, I did. In theory, it should start and run, and we will measure that capacitor voltage right there. 16 volts right now. And it stays 16, oh, it dropped to 15.7. See, that's interesting, I think. It drops maybe a volt. Maybe a volt. That's pretty rock solid. It's not the diode, is it? The rectifier. Well, a cat has made its way into my workshop. What do you want, Griffin? Come here. Introducing the world's largest land mammal. Dr. Gryffindor Fluffy Bottoms. Come on, Griffin. Let's go. I know I didn't give your midday kibble. Take it up with the union. Okay. So this one doesn't drop like that. Which would make you think something is drawing more current than it should. What if I feed in 16 volts to this good supply? I'm curious what the normal current drain looks like. How much current does this thing have to supply? I'm just gonna, basically I'm gonna give 16 volts. Well, let's see. Yeah, I'm after this, let's see. Am I after the switch or not? Right here. Yep. Doesn't draw any current because that's before the switch. You would have to go over here. Nope. Still not getting any. Oh. Because I got the wrong leads. Wrong leads, that's the ones going to the load. All these leads look the same after a while. So if I give it here, 2 milliamps. What if I go over here? 30 milliamps. All right, if I provide 16 volts after the switch, 29, 30 milliamps. So that's the most it's going to be, the most it's going to have to supply is 30 milliamps. That's with, of course, this board is fully working. It has both chips installed. The 12 volt converter and the PFC are both in there. So 30 milliamps is basically what that supply would have to, what you'd have to supply. So why can't it supply 30 milliamps? What are we discussing? Everybody leave yet? How long have I been streaming? Way too long. 3.5 hours? Three and a half hours, huh? So, 30 milliamps. That's all you have to supply is 30 milliamps, and you can't do that. So, the 15th. Huh. What else is there? There's a ferrite bead. There's a 0 ohm jumper, J33. And then we hit D21. Where was I? Who am I? All right, I put the board down the wrong way. So, that's D22. Oh, D21 is down here. It's on the other side of the board. It's right here. Anode is on this side. So this is where it's coming from. There's a 0 ohm jumper. Let's make sure that thing has not opened up. I've seen them do it. I don't know if I'm that lucky today, but I've seen those 0 ohm jumpers open up sometimes. No, she's good. She's good. Otherwise, we just have a ferrite bead. That looks fine. There's that Zener. I don't think the Zener's bothering us. And then we have the winding of the transformer right here. Now is there a C23? Those things, they use like a resonant cap across them, I want to say. And if it opens, weird things start happening. I was looking at I was just looking at reasons why this thing might not be able to supply as much as it usually could. Could the transformer be bad? That's possible. But it sure seems to put out the right voltage without a load on it. We've got ferrite bead, 0 ohm resistor, which seems to be fine. Diode, I don't know, could the diode be not dioding too well? The 2 ohm resistor, I think measured, we didn't, I'll measure it. We didn't see any losing much voltage across it, much drop. 2 ohm resistor, 2.02. That's pretty good. So you can't see it. Take my word for it. I guess you won't take my word for it. I was checking that 2 ohm resistor, which is in series. And she is 2 ohms all day. So this diode here seems to be just fine. 0.5. I mean, seems to be just fine. 0 ohm jumper. There into there. But there is this capacitor. It looks fine though. C23. You notice it's right across the winding there? There's a reason for that. Without it, that voltage would just be low as everything. Without that, it's like a resonant capacitor. It's going to be hard to check. It's only, it says, the schematic here says it's 56 picofarad. That's not a lot of capacitance. Kind of hard to measure with this thing, but 57.9 picofarad, 58. That looks absolutely fine. I mean, it wasn't. I don't think it's leaking or anything, is it? I'm gonna say it's fine. Again, no problem there, I don't think. What does my meter say it is? I can't really read it too well, I don't think. Yeah, she's getting up there in it, 56, 58. Fine, I think. Resistance. Just looks fine. Now what about these transformers? Look the same. I wondered if they had changed something. No, I don't think I see any physical damage to it or anything. It looks pretty darn good. It looks healthy because it does have an outer case to it. So I don't have everything on here right now. So if I give this 16 volts here, I don't have the chip on there. Okay, that's interesting. I don't know if you can see can you see the bench power supply? I'm injecting after the switch, after the transistor that switches this voltage over there. Well, if I can get on the, yeah, 28 milliamps. And one of the chips is off the board right now. You know what I mean? The DDA001 chip that makes the 12 volts would use this same rail. It's not even on the board right now. The good one pulls 30 milliamps with both chips on there. The plot thickens. It's like we're splitting hairs current-wise, though. But yeah, she's drawing 28 with just the one chip on there. Now that DDA001, we don't know its current requirements because there's no data sheet on it. Hard to believe that they would design this thing to run that, you know, to run that close to its limit. You know, like I can supply 30, I can't supply 40 milliamps. That doesn't seem right. But something is different. There is a relay. It's for bypassing the, like a surge, I guess it's an NTC. You can hear it clicking. Yeah, there is a relay. Right there, bypassing this NTC, like let's say in rush limiter. And I think what it does, it lets the current go through here, and then click, and this closes and bypasses it. What is, hang on, my phone is killing me here. Oh, we're approaching 4 hours. I'm gonna have to take a break, guys. Shall we continue this? Maybe tomorrow? Oh, yeah, I think I'm taking a break. We're close though. Yeah, we are close to solving this because it's acting. Yeah, it's close. I mean, we've seen it run. We know if we put a load on the 5 volts, it'll run. But okay, all right, we'll continue this. I may figure it out off stream, but we'll continue it. Well, thanks for coming by, everybody. It's been fun. It's been an interesting one, hasn't it? It is interesting. I learn a lot doing these kind of things. So anyway, yeah. See you later, guys. I'm gonna get something to eat maybe and play a game or something. So we'll catch you tomorrow, if not sooner. If I don't figure it out sooner. So see you later. We're not done with it.